The last few days, most of you, are all of us that way, have been highly excited with the news going on around with respect to science and technologies. And one question probably might come to your mind, that whether chemical engineers do have any scope to the space industry. No. I think it is there, very much there for you, lot of scope for you to work in the space industry too. Many friends of ours from chemical engineering background, they have been working and still working. Few of them have retired. So you can also probably, as inspiration or motivation, think of joining space industry or space programs of the country, not abroad. Don't go to NASA. You have got plenty of things to do here itself. So everything what you can think of in any international laboratories, you'll find it here in our own ISRO. Okay, I being from a DAE family, Department of Atomic Energy, and post my retirement, I joined academics in IIT Bombay and teaching there, and still teaching. I wish to just ignite your young mind, that think of big. I'm sure you will do big things in the life. So, and never get disheartened with one thing at least, that where from you are graduating. You see, I think is important, but not that important once you enter to any, say, practical works, And it is since I was there, as a placement officer also, I just asked few questions to some of you that whether you got placed or not. So since I was placement officer in my previous assignment, so in MGM college, and I do tell that academics is certainly important, where you must get good grade, good marks, and all those things are fine. But there is academics, but more than the academics, another two are very important. What we call it, your attitude and your aptitude, and that counts you around 66% of your marks. So you may be doing very good in academics if you are not very good in your aptitudes, in a clarity of your mind what you want to do, and also your attitude towards the things happening in and around you, how you deal with your friends, how you deal in your team, and many more such things that you must have seen. Hundreds and maybe a few hundreds of the scientists and engineers working together, and the dot time predicted by ISRO, 6:04, they are just little before than that, 6:03. They entered and they set the things right. So many uncertainties were there, and that probably in your redundancy is the one which you can understand as an engineer, that is very, very important for you to understand. Redundancies. So in case if it is not feasible, what next can go. So I think Dr. Pandit is here now. So I was wondering where the voice is coming. So Dr. Pandit here now. Please enjoy the program for the day, and thanks for coming here.
Parag sir is busy. Usually when I'm coming to ICT, मुझे आदत कम रहती है because Parag sir is there means. Okay. He'll be coming, sir, I think. Yeah. So, I think we can start today's session. And we are a little late, but although we'll cover up and make sure that all the waiting is justified very well. So, first of all, welcome to all our IIChE members, students, and basically from chemical engineering fraternity. We are happy to have today our 63rd AGM, and on that eve to have half day this seminar from Dr. Parab over here and Mr. Timothy Bieri, that is from British Petroleum, and I thank Dr. Mudli over here for having such a quick response and arrangement. And earlier we were supposed to have it on dates like 28th or 30th, but as I informed him that we have AGM, and being the past chairman, he is supposed to be here. So so it was done like within 2 days time, and we are happy to have you, sir, back over here, because earlier he was here and then he became VC. Welcome back to Dr. Mudali. Okay. So welcome to all our Srivastava ji, Trivedi sahab, MP Jain sahab, all the senior, Nageshri ji, our editor. We have presence of all the students, and I think faculties are also around. When people come to ICT, they start touring ICT first, I think. So, but still we have presence of Datta Mege, Thadomal Sani, and I think Jonle College from here, apart from ICT students. So, thanks a lot for coming up for in such a short notice. I would like to now invite our Professor E.B. Pandit sir, the chairman of our IIChE MRC 21-23, to sir, please. I think he needs no much introduction because already well known and teacher to many, even me. So.
First, let me just welcome. Well, on behalf of Institute of Chemical Technology, I am happy to see you all and welcome you all for the annual general meeting of Indian Institute of Chemical Engineers, Mumbai Regional Center. We usually have some sort of a lecture associated with the AGM, and in fact, we are fortunate to have two lectures this time. First lecture is understanding the concept of sustainability, and the topic is sustainability developmental goals. So whenever we talk about progress or development, how the progress and development can be combined with sustainability is a question which everybody has in mind. And at the end of the talk, you will all realize and understand that chemical engineers are the one who are most suited to understand this concept and translate it and implement it. So Dr. Shrikant Parab, who has agreed to give this particular talk, I'll introduce him in a minute. But before that, what I would like to tell you all is ICT, you all know, is involved in area of chemical sciences since 1933. We are celebrating 90th year of our existence this year. So on 1st October 2023, we will be completing 90 years of existence. And ICT has a niche area in the area of chemical sciences, and if you see the kind of who's who in the chemical industry, you will find that they have some sort of an association with ICT. The well-known alumni who have gone on to excel in their respective fields are Shri Mukesh Ambani, then Dr. Anji Reddy of Dr. Reddy's lab, then we have Shri Madhukarbai Parekh of Pidilite, Fevicol fame, then we have Shri Ashwin Dani of Asian Paints. All these big companies, chemical companies, including Dr. Narottam Saxeria of Ambuja Cement. So you'll find that the chemical engineering field covers the entire pharmaceutical to construction, and ICT has had some role to play in it. And this legacy continues, and in fact ICT started in 1933 with the desire of industry, because at that time Mumbai was a textile hub. So the two courses of chemical engineering, chemicals related to textile processing, and textile chemistry and technology were the two courses which were started in 1933, and subsequently other chemical sciences areas such as pharmaceutical chemistry, food chemistry, polymer chemistry, surface coating chemistry, specialty chemical chemistry, oleochemistry, and technologies associated with were added over a period. So we have currently 9 departments, 7 departments of technology, 1 department of chemical engineering. Another department which is just initiated was Department of Biological Sciences and Technology, and we plan to start a new Department of Humanities and Management Sciences. under the National Education 2022 program, it is necessary for us to have majors and minors in each of these, and we will be starting this year, and the students who have been admitted to ICT in the year 23-24 will be the students who would be graduating with a degree, a major in chemical engineering and a minor of their choice. One more thing which I would like to tell you is when ICT was started in 1933, India's first 4 PhDs in engineering and technology came out of ICT. Along with the undergraduate course, the research started simultaneously 1938, 1939, 1940 and 1941. 4 consecutive years, the PhDs in engineering and technology from our country came from ICT. So ICT has that legacy, and we all are very proud of it and work very hard to take this legacy forward, keeping in mind the changing trends, keeping in mind the changing environment scenario, and that's why today's first topic of sustainable development is of special importance to all of us. So may I request Dr. Shrikant Parab to come on the dais, and let me take this opportunity to give you a brief CV of Dr. Shrikant Parab. I have known him for past several years now. I've worked with him, and I thought he is the right person to address us all in terms of this particular area. He is a founder of DSP Business Advisory Company. It's a long biodata, I'm not going to read all of that, but I'll tell you what is more relevant to it. He is considered as a youth icon in environmental sector. He guides young adults in every aspect of environmental related issues, and more than 2 lakh people of various age groups have attended his seminars and have taken cleanliness pledge with him, and he will give many examples and experiences of his journey through that. Besides cleanliness, he has also started initiative for youth named Oxygen Factory, where essentially you do tree plantation and have trees producing oxygen, and you will see the difference which you see, and he will also tell you the success which he has had in terms of sapling plantation. More than 30,000 plantations, saplings have been planted and they are maintained. So he has carved a niche for himself, having earned a unique reputation of being startup specialist, triggering growth to many organizations in the IT sector, e-commerce section, telecom, BPO, while keeping in mind the issue of sustainability and cleanliness of the environment. By education, he is a bachelor's degree in commerce, master's degree in economics and business entrepreneurship, postgraduate in computer science, honorary doctorate from St. Mother Teresa University, and then various certificate courses related to the computer science and related issues. Awards and recognitions: gets an award from Emirates Airline, Knight of ICC Award from Israel Commerce Community, Young Entrepreneur Award from Dubai Chamber of Commerce, Gaurav Andhericha Award for Cabinet Minister from Maharashtra, and Nelson Mandela Global Peace Award at the hands of Union Minister Shri Ramdas Athavale. So he's the right person to address us all at the start of this AGM of IIChE MRC, and I'd like to thank Dr. Shrikant Parab for accepting our invitation. And without ado, I would request Shrikant to start today's discourse. Thank you.
I should say good afternoon everyone, and thank you ICT for inviting me here. I'm going to share my experience more than the knowledge, and knowledge I gained from the experience rather, because we study a lot from childhood. Nowadays, from childhood, they teach us about climate change and all those things. But practically doing it is a very different thing. It's, I would say, it's fun. And if you really want to bring the change, then you should implement things rather than just knowing it or studying it. So unless and until we implement or we use our knowledge, I think we will not be able to bring the difference. And that is exactly what we try to do here. There are about 17 sustainable development goals set by United Nations for the future. Because everything is changing. I mean, the childhood that we have seen, I'm sure today's kids will not get to see that. Many changes have occurred, and we have to adjust ourselves with those changes. Having been said that, some habits of ours, human beings rather, has changed, is a cause of this particular change. So I always say that every step towards development actually takes us towards destruction. So there was no industry earlier. Now there is industry, but that industry is also causing a lot of damage to the environment, polluting environment, water bodies, etc., etc. So every development actually takes us towards destruction if we don't take care of nature. So whatever we do, that sustainability aspect or the nature, we have to keep in our mind. And that is exactly what we have been doing. My journey in environmental area or arena started 14 to 15 years back when I was introduced to waste management. Somebody gave me a solution, and I thought I had a magic wand. Waste to energy was something which was presented to me. 2 years I studied that subject, and I said, yes boss, this is what we need. But when we actually started doing waste management, I started approaching the municipal corporations, urban local bodies, government, etc. I realized, boy, it's not that easy. It's very difficult. And I alone cannot change it. There are so many people. There's a system, the whole system there, which needs to get changed, or their thought pattern has to change. And but one thing happened during that particular study is that I visited almost 3 or 4 big dump sites in the city, like our Devnar, which is actually on 326 acres of land. More than 3 crore metric ton waste is lying there, and nobody is doing nothing about it. So that made me think, and I said, okay. And then study also showed that people around, staying around that vicinity, that area, they are facing a lot of health issues, and the average life expectancy in that area is only 39 years. So many kids are dying there. And then I realized that this waste is our waste. Somebody collects it and throws it there, but at the end of the day, this is the waste that we have collected, we have created. We are the waste generators, and that waste goes there, and it is impacting or affecting somebody else's life, even taking lives. So that means we are murderer in some way or the other. And I wanted to remove that label from my head. I said, I don't want to be part of it. And that's why I started Zero Waste at Source program in year 2012 in our society itself. So we started that from our journey. That journey started from there. And now we talk about all 17 sustainable development goals. And most of them, they are out of 17 goals in our society, we have implemented almost 10 of them. Because we cannot do everything. But whatever we can, we should, is the funda. So I'm sure everybody knows about those 17 goals which we are talking about. And I'm just going to talk about my experience, what we have done, and how we are contributing towards this particular vision of India government and the global leaders who are talking about, climate action plan. So 2012 when we started waste management in our society, it was very difficult because again those basic questions, बास आएगा, हमारे घर के पास क्यों, मच्छर आएगा, वगैरह 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 was there. Managing committee was not even ready to give us 10,000 rupees to set up one unit. And then I had to fight with the managing committee. They still didn't agree, so I said, okay, we'll use the open space. I did one Honda car display in our society and earned some money out of it and used that money to set up the first waste management unit in our society. It was vermicompost, which is historically proven method, earthworm based composting system. So we started with that. Today we have about 4 such units in our society. We manage about 20 tons of waste in our society in those 4 units. Then we moved towards biocomposting, which is a bacteria based process, and that is used for your leftover food or mixed food, which is like, it also handles non-vegetarian food, etc., etc. So we started with that. It's a simple solution, and we have so far processed almost 700 tons waste in our society itself. Then we moved towards the community side. Started with 5 or 6 families. We told them to do this. It worked well. It was a kind of a pilot. Then 25 families, and now I'm proud to say that 100% segregation happens at source. We segregate waste in about 11 different categories. Out of that, 2 categories in wet waste, biocompost and vermicompost, and other categories are like plastic, metal, cardboard, etc., etc., etc. And finally, medical and hazardous waste. That medical and hazardous waste is sent to BMC for incineration, but rest everything is being recycled in our society. Then we move towards community, and that is also part of one of the sustainable goals, that you have to spread the ideas and improve the community also. So we implemented this model in 40 societies in Mumbai, and we so far have prevented almost 7,000 metric ton of waste from reaching the dump site. So this is a sustainable solution, I would say. Scientists and there are many scientists who are working on it, and there are many technologies they are coming out in the market, but many of them are for the bigger projects, or you say larger projects, and it takes time for those projects to happen. Like we have presented one solution to central government to eliminate the dump sites in its entirety. It has been almost 4 years we are working on it. It's going very slow, moving very slow. But that is also one of the sustainable solutions. That's almost 17,200 crore ka project. It's a big project. So that is happening there. But at source you have to work. Somebody has to do that job also. And I think we are the ones who are the right people to take it forward. Besides that, we have also set up the, besides waste management, we have also installed 2 rainwater harvesting systems, recharging underground water table up to about 10 to 12 lakh liters every year, year on year. We do tree plantation every year in our society. First I'll talk about our society, and then we'll move towards the community side. So we plant almost 25 saplings every year. So we have a very good green cover in our society. We maintain biodiversity. And I was just telling sir that we have, in our small society, we have identified about 21 species of different birds coming in. We maintain that. We also have a feeders for our squirrels there in our society. So we take care of all those things. We have adopted 5 stray dogs. We treat them. Every year we vaccinate them. We feed them 2 or 3 meals in a day, etc. So we take care of them also. So life on earth, life under water, all these things we take care of, which are part of your sustainable development goals. We have a small fish tank in our society that we call it's like an orphanage for fishes. So many people, out of, kind of a fun, they buy fishes and later on it becomes very difficult for them to manage. And then they just throw them away or kill them. So we allow them to put it in our tanks and we maintain them. We have got two natural whales, and when they grow, we just put them into the well and allow them to live their life. So these are small things, everybody can do or anybody can do. And I think we should do that. This is exactly the Sustainable Development Goals talks about. Poverty, deal with poverty. Okay, nobody should be poor, everybody should have some, at least their day-to-day life should be comfortable. Nobody should go hungry to bed, is what Sustainable Goal talks about. Right to education, that is what Sustainable Goal talks about. We provide free, interest-free loan to our employees or your domestic workers or helpers for their kids' education. For their kids' education. So that also we do. So not necessary that you have to take any big steps to achieve these goals. But I would say that today our society has become a model society. If we replicate this model into all societies, I think the change will come automatically. And this is what I wanted to share with the audience here. We have done a lot of different changes or small changes in our society. Like renewable energy, we have solar plants. We have reduced our electricity consumption by using the LED bulbs instead of the earlier mercury lights. We have done that. You just name it and we have done it. We have also made use of the technology in our society. So lifts or the elevators that we have used a very advanced elevators to reduce the consumption of the electricity. I think this is at society level what we have done, and we are replicating it. We are getting associated with many groups who have the reach to the societies, and we are going to bring the change as much as possible. Now at the community level, we are just taking this model, but besides that, we are also working on involving people into this program. So for example, I have reached out to more than 2 lakh people all over India through my seminars, online or offline seminars, and many of them are connected to us now. So we have provided them solutions, we have given them the assistance, we are hand-holding them to take the whole thing forward. 30,000 trees that we have planted in Mumbai as an urban forestation or oxygen factory. We have just given a funny name or for kids to to attract kids. So we educate them what exactly the trees, how exactly the trees function, why should we do tree plantation, why should we conserve them, etc., etc. Then some statistics we give them, how much oxygen we consume every day, and you should generate oxygen, produce oxygen more than what you actually use, etc., etc. So we give those lectures, and then we involve them in tree plantation. So we have planted more than 30,000 trees in and around Mumbai, and the drive is going on, and we have a target of almost 100,000 trees that we are going to plant very soon. That's going to be a big plantation drive. Very soon we are going to do that. Maybe next monsoon we will plan that. So I have reached out to many colleges, give lectures and involve them. So every Friday, Saturday, the kids, they come. Somebody is involved in making the saplings. Somebody is involved in, plantation. Even some NCC batches, they come and they dig the pits for the plantation thing. And they all enjoy. So one story or one incident, recently one lady came to my office and she brought a bouquet. And she said, "This is for you." I was amazed. I mean, I asked her, why this bouquet? And so she said that, I would like to tell you a story. In Manori area, we do this plantation. And her daughter was about 4 years old or so, 4.5 years old. And she used to come regularly with her for tree plantation drives. And now she is so connected to trees. that when they went to their native place and few people were trying to cut the tree, she just stood in between the tree and them and said, "Dare you touch this tree? I will not allow you to kill this tree." And this is what she does everywhere she goes. Wherever she sees people damaging trees, cutting trees, she actually tries to protect that tree. And she said, "You have changed her life completely." So I think, it feels nice when your small effort actually brings change even in one person is actually achievement. That's what I feel. And we have almost, I think, I would say about 25 to 30,000 students who have participated in such tree plantation drives with us every Saturday, Sunday. It was an exercise, and I had to go every Saturday, Sunday there. Similarly, waste management also happened the same way. I mean, we started with a small process in our society, and in 2016, when government of Maharashtra came out with the waste management rules, solid waste management rules, and when municipal corporation imposed some rules or laws on the societies, one fine day I started receiving calls from all over Mumbai. And I said, I didn't understand why they are calling me for waste management and all this kind of stuff. Then I went to Worli, one of the societies, and I asked them, "Who gave you my number?" So they showed me the notice we received from municipal corporation, and on back of that notice they had written my name and number, and they said, "Call this person," because they did impose the rule, but they didn't know what to tell these people how to manage their waste. And all of a sudden I started receiving calls, and of course I attended many of them. I went to many societies, helped them out, and I think those 40 societies at least which we implemented this solution is still working. After that, that OWC model came out and many things happened. There was opposed to what we were doing, but then they didn't have any solid grounds to stop us doing from that, and it continued. So now also we are continuing in that particular direction. I think what we have done in our society, if everybody does that, at least that, it's a small thing that what we have done. Just look at those 17 sustainable development goals. I'm sure many of them we can take care of at our level. Even if you sponsor, when we talk about education, even if you sponsor one student who's underprivileged, I think we have done it. When we talk about nobody should go hungry, just sponsor one family if you can. I think that will also help. So, for example, even this life on earth, when they talk about birds or your stray animals, adopt one of them. Don't take it home, but at least take care of that particular animal, and it will definitely help. I mean, they go angry, they bite people because they are hungry or they are injured or whatever it is. They are in pain, so they become aggressive. If we take care of that, then I think situation will change for sure, 100%. We have adopted 5 in our society, but we take care of 40 dogs altogether. Their feeding and everything we take care of, and they are very happy dogs. So when we go, they wag their tails, etc., and they actually show respect. So I think बहुत छोटी चीज़ें हैं, I think we should take care of. Squirrels, in our society we have attached those baskets to the trees and we keep peanuts there, so which is their favorite food. So they come, and at that particular time we see they come and they take their feed and they go. We have bird feeders, etc., etc. These are small things, because again, peace and happiness is also one of the sustainable goal out of the 17. So if your surrounding is good, then I think that peace and happiness will come automatically. I'm supposed to talk about my experience, so I'm sharing it. So sometimes I get emotional. 2011, our society was in a dilapidated condition. There were fights. We used to enjoy AGM because every AGM there used to be fight, and we used to go there and enjoy the fight. 2011 I came into committee accidentally, okay, and then 2011 itself I became secretary of the society, and then entire facelift was done. And today our AGM, there's no fight at all. Everybody, it's like a celebration. People, and especially the senior citizens, they enjoy coming to AGM. They enjoy. We have a very, jovial time. We enjoy. We just crack jokes. And AGM, I mean, I have hardly seen in any society AGM the way we conduct in our society. It's fun. For them, it's a fun event. So that is peacefulness, happiness. No, I mean, we have taken, anybody gives any suggestion, we actually evaluate that, whether it is possible to do or no. If yes, do it. Why not? If that makes one person happy in the society, that is also good. So we have done all those things. I think our society is very happy, healthy. Average age is in our society is about 80 plus. That's the life expectancy in our society. That is because we have a very good green cover. I think the AQI outside our society and inside our society, there is at least 10 to 20 points difference. That is because trees are natural carbon absorbers and sequesters, so we have got a green cover. We clean our society every day, twice, so no dust. Many factors are there which we take care of, and people are very happy. So I think out of those 17 sustainable goals, even if you take care of 5 or 6 or whatever is in your capacity, and as a community definitely it is going to be more. Now we are working on EV, we are convincing people will go for electrical vehicles, and we are trying to make our society a carbon neutral society. So all parameters we have already designed, and we are now ticking one by one. So, towards getting carbon neutral. Our society has received so many awards. I think this year we received 2 awards, one from Godrej, and second from there's an Envirno Care company who organizes these international awards, and we got sustainability award this year. Just last month we received that. So we didn't work for awards, but eventually point is that we get noticed that you have done this also, this also, this also, this also. And for any society to do this with so many members in it, I think it's an achievement. But yes, I'm not saying that everybody will be able to achieve everything that what we have done, but even at least some part of it, if you can achieve, that would definitely help. So by saying that, I think I would stop my speech here or lecture. And anybody wants to do anything in any of this space, make use of our experience. We will make ourselves available. We will handhold you. We will take you forward. A lot of funds available. CSR funds available. Society has funds. Many societies have funds. So let's do it. Let's take one step forward and achieve these sustainable goals. Besides that, now, sorry for that. While working on these grassroots level things, I was also working on some bigger solutions. And there are many technologies available. Many scientists in India are developing technologies. We should encourage that also. Make use of that technology, try to commercialize it. That's the second aspect I do from my Dr. Shrikant Parab business advisory, because unless and until you commercialize any technology, I think it will not go a long way, and it should not remain at the lab level. It should move forward, should get used, and that is exactly what I do. So on waste management side, we are trying to promote as many as possible the local developments or the technologies which are available. For wastewater also we are planning many things. Government of Maharashtra has set a task force for air pollution control. So there's one product developed by IIT Powai Vayu, and we are actually working on that and making it commercial. And in solar, we are in solar space, so we have we have introduced some very new solar panels. It's a German technology, and we are bringing in technology in India. We have already spoken about the technology transfer, and we are going to start manufacturing in India by next year. We'll achieve that goal. Very unique solar. They are 2 mm thick, unbreakable, scratch resistance, semi-moldable. Longevity and ruggedness is there. So many features are there, and we are actually proposing government of Maharashtra and any other state government to take this particular model and achieve that green energy target that government of India has set. Our goal is to become carbon neutral country by 2070, as announced by our honorable Prime Minister. And unless and until we all individuals participate in that particular drive, I think it won't be possible to achieve that goal. So I appeal all in this, everybody should do their job. Scientists will go on developing the bring new and new technologies, but at the grassroots level, everybody can do something or the other. So we are, whoever we are, even if I am a Prime Minister, I am an individual. Even if I am a finance minister, I am an individual. Everybody is an individual. Even if I am an entrepreneur, I am an individual. So at individual level, whatever we can do, I think will be really helpful in achieving our long-term goals. Let's look at us as an individual, and what can I contribute towards this goal is the most important question we should ask ourselves and decide what we can do. So by saying that, thank you very much. If you have any questions, I am ready to answer this question.
Students, if you have any questions, comments, this is unlike any technical talk you hear. This is a talk which is coming essentially from a person who has experienced it himself, practiced it. We all have a subject called EVS, Environmental Studies, in our school. During our days, we did not have that subject, mainly because we were always outside. We used to be in the vicinity of environment, but the younger generation is sitting in front of the computer, sitting in front of television, so they need to be made aware of the environment which they live in. And what Dr. Parab essentially talked about is his experience, is how an individual can make a difference. Even if you just follow in your own, is a kind of an example which I gave to my student is, being a chemical engineer, you always study with the first subject, which is material energy balance. Try yourself, try doing it yourself. Is what is your carbon footprint? What is your water footprint? What is your energy footprint? Just sum up, calculate all the activities which you do during the day and find out to what level you are contributing or to the environmental degradation, and how a change in that activity format will allow you to stop that. And what Dr. Parab essentially talked about is working at an individual level first, then working with a community level. Community level means you and your friend circle, or your class, or your college. So you have the whole world open for you, and it is necessary for you to just be aware of your actions. And sustainability essentially only means that we should be accountable for our own action. It is not just making money at the end of it, but money for how long? When we say sustainability, sustainability for what period? Sustainability for 2 years, 1 year, 100 years, 200 years? We need to understand this concept first. And this starts with the first understanding of material energy balance of our own self, and try to identify the areas where we can contribute and continue to contribute and reduce our own environmental footprint when the way we live our life. So I would like to thank Dr. Parab and compliment him for making you all aware of a slightly philosophical tone of today's talk. And if you have any questions, please feel free to ask him, because he will tell you not necessarily in the form of equations, but he will tell you in the form of stories, I'm sure.
Yes, we have the record. I mean, how much water we have conserved, how much, I mean, carbon footprint, what is our carbon footprint, how much we have been able to reduce is what we already have numbers about that. And now we are developing an application for every individual to map their carbon footprint and what steps they should take to reduce it or to kind of offset it. So that also we are working on right now. But yes, yeah, sure. So my focus was always at source, and source is us. It's not society or it's not home, it's us. We are the source. So working on source is very, very important. Think about it. Thank you very much.
So we have sort of recovered part C, and yeah. So I'm going to hand over the mic to our past chairman, Dr. Kamachi Murli, to take over the next lecture and the next set of talk, and give a background about the next talk and what we can expect and how it is complementary, supplementary to the activities of chemical engineering profession. Will be followed by the lecture of Dr. Timothy Bieri. Kamach, please.
Yeah, he has just read actually. There was an announcement by Mr. Samir actually, so he has also gone there.
Yes,
So,
yes, they're just outside.
yeah, I think we'll take just 5 minutes till. तब तक actually I wanted to ask him a little bit, Dr. Parab over here, because what he mentioned is at the end of I think his talk that commercialization of anything is very, very important, which I feel many times is the missing part whenever anybody does any project, specifically in engineering. You know, when students or UG students, they focus on technology, but why this technology we are going to choose for our project. So all these things needs to be, focused in the right way, that how it can be commercialized. So I think if you can give some example of how you choose a technology like that. So I think it will help our youngsters.
I think it's a very important question, and through my business advisory, I try to do that. We evaluate the technology. We have arrangements with various national and international funds, because for commercializing any technology or making it, you have to scale it up, and to scale up, you need finances. So finance is the backbone of commercializing any technology. So we have got groups, we are associated with many groups. Government gives a lot of funds also, but that's a very cumbersome process. Everybody doesn't get it. But some people can actually get funds from the government, but more or less technologies don't take off because of the finances, and one of the aspects is that which we take care of. So we evaluate technology. The technology should be at least, whoever is developing anything, any new model, any new technology, should consider at least next 25 to 30 years. We can't just think कि आज ये situation है तो आज की situation के लिए ये solution अच्छा है, That's a temporary solution unless and until you look into the future. And that vision you have to have. You have to visualize the change that might come in next 25 to 30 years. Because situation will never remain the same. Today this is the situation, 25 years down the line it's going to be changed. So you have to evaluate that change also and develop whatever you develop. For example, in 1999, I started developing one ERP system of my own, because that time only two ERP systems were in market, called Oracle and SAP. Everybody, some of you must be knowing about that. These are the financial softwares. And there were many Indian technologies, Indian softwares, but they were very, I would say, short-sighted products. So we started developing a product called Cornucopia, which was an ERP system. Cornucopia means like Akshay Patra. Whatever you want, you can just pull out of it, kind of a thing. That's a cornucopia thing. So we developed our own ERP. After that, 9/11 happened, and then IT industry took nose down. I lost a lot of money into that project, but at the same time, that technology, even today, that is not obsolete. Welcome, sir. So even today, we can actually use that application as it is. That means you have to have that vision to look into the future and develop something like that. Financial help will come. I mean, definitely we'll share our numbers and everything. So anybody has some good technologies, we would definitely like to connect them to the right groups who can take it forward. Yeah. So finance is the core in commercialization of the technology that we take care of.
Right. So I think very rightly said. And when we have over here Parvatalu Saab from ONGC, I think working for so many projects. So when they work out, and I think sir is also from former ONGC, but when they work out, what are the commercial aspects of any project that needs to be worked out in a very optimized manner, or you need to work out like what are my raw material sources, what kind of technologies I am going to use for getting my utilities down there, and what is going to be the cost of the product, and then comes the direct finance part. So, and if there is a end-to-end meet, then we say the technology is sustainable, and engineers over here have the major role in it to make it commercialized and make it available for the people, society. So I think now we can go ahead with Dr. Mudli sir.
Good evening, Professor Pandit and the members of the Governing Council of IIChE MRC, dear students and other invitees. I am very delighted to be here, and after this wonderful, I would say, discourse on sustainable development goals, there are 17 goals and 269 targets. And this was set in the year 2015. The United Nations General Assembly with a target of 2030. It's called Agenda 2030, that every country, all 154 member countries of UN General Assembly should implement all these 269 targets under the 17 goals to see that the earth is becoming livable and it is made available for the future generation. We are today discussing so much about climate change. We are discussing so much about the earth becoming warm. I think warm is no more there now. Today it is called boiling. The earth is called earth warming. Global warming is gone. Now it is global boiling. So temperature going to shoot up. To people are predicting that 2 degrees is going to happen by another 50 years. Then it will happen so that even part of Mumbai, people predict that will be submerged in water, because there will be a lot of melting of ice in the glaciers, and this will lead to total change in the environment in the whole over the world. So it was very interesting to listen to Dr. Krishna Parab, who made an excellent discourse on that. Now we have a technical presentation. There is something that IIChE want to give you both, something that is belonging to the environment, and now that is something to the technical part of it. We have with us Mr. Timothy Bieri, he is the Vice-President for Materials and Corrosion Engineering with British Petroleum in Houston. And he has over 30 years experience in a broad range of engineering and leadership roles, including global multidisciplinary engineering teams in the areas of mechanical engineering, and integrity management, supporting both projects and operations. He has covered disciplines by teams which include static, mechanical, rotating equipments, corrosion inspection, corrosion materials, welding production, chemistry and inspection. Approximately half of this experience has been spent working with aging infrastructure in harsh environments. He is a registered professional engineer, certified internal corrosion specialist and cathodic protection specialist. Mr. Bieri served as an officer on the NACE and AMP. The NACE is the National Association of Corrosion Engineers. AMP is Association for Materials Protection and Performance. He was in the board of directors. He is the first chair of AMP, and he is the inaugural chair of the AMP and then the board of director in 2021. And before I call Mr. Tim Bieri, I would also like to introduce Mr. Dr. Samir Degan. Dr. Samir Degan is the director of Corcon Institute of Corrosion, and along with Mr. Anand Kulkarni, another director of Corcon Institute of Corrosion. The Corcon Institute of Corrosion has the responsibility of providing the Association for Materials Protection and Performance, a scheme called EMERGE, which is an India scholarship, and this is done for the last more than 10 years, starting with NACE, now with AMP. And this scholarship, 10 numbers are given every year. Each one is 1.5 lakh. And the eligibility is that the applicants must have enrolled full-time PhD or MTech in the field of corrosion science and engineering. Applicants must have a permanent residence and attend a college, university or institute in India. And postdoctoral associates are also eligible to apply. And every year by January, these applications are welcome from the students who are doing MTech, PhD as well as postdoctoral fellowship. And these recipient of this AMP EMERGE India scholarship are eligible to receive a travel stipend to subsidize their travel to the AMP annual conference plus expo, and are recognized in person at the scholarship award ceremony during this annual event. And attendance for the scholarship award ceremony is mandatory to receive the stipend there, and travel assistance will be available for the recipients at the conference registration area and the designated day. And every year this AMP annual conference is plus along with an expo is held in USA at different parts, and I think for the year 2024 it is going to be held in New Orleans. So those who are interested, I think before January they should apply, and you have I think all students have been given a diary which is containing the details as well as the link and the address to contact and apply. And if you are doing anything related to corrosion, please do not hesitate and do your application, send your application to Corcon Institute of Corrosion. So it is now my pleasant duty to invite Mr. Tim to deliver this lecture on risk and corrosion management.
Good evening, or late afternoon, depending on how you look at it. I'm Tim Bieri. I'm with BP. As was said, I work in Houston, Texas, but part of my role in BP is to provide or ensure that we have competent and capable workforce in the area of integrity management. So that includes materials, corrosion, inspection, and erosion. Reason I'm in India this particular week is we're getting ready to set up a technical service center in Pune, and we're doing all the legwork to put that in place and begin recruitment over the next 6 months or so. So it's going to be interesting as we. What?
You can mention that a lot of alumni of ICT or.
Yeah, we have several alumni from this organization that work for BP. Several of them in my broader, not my team, but in the engineering team, and very familiar with them. So they're going to be jealous that I'm here talking with you today. I'll go on with the presentation. Really, this is a conversation about risk and how corrosion management plays into risk. But the concept of risk and risk management plays in any industry, in any role that you might have. So it's not focused entirely on the corrosion piece. I'm going to start with what the pipeline infrastructure looks like in the United States. So we have a regulatory body in the United States, part of our U.S. Department of Transportation. The regulatory body's name itself is a mouthful. It is the Pipeline and Hazardous Material Safety Administration. We call them PHMSA. This is a map of the regulated pipeline transmission, gas pipeline, and transmission of hazardous liquid pipelines. So you can see there's a lot of miles or a lot of kilometers of pipe. What isn't represented on here is distribution pipelines that would take it from a transmission line to a place of business or a place of residence. So PHMSA has a really nice database that anyone can go and mine information from. So some of this data comes from that database. They have a category of failures called significant incidents. And those are the definitions there. It has a financial number and or a safety number. Was somebody hurt? How much was the cost? So we'll build some of this data, and if we look at 3-year, 5-year, 10-year, and 20-year, those are the total number of these significant incidents. Let me click one more time. You guys can scan this QR code and go look at the data yourself if you're interested. You can see the number of incidents, the number of fatalities, and the number of injuries. And this isn't just specific to corrosion, this is across the whole spectrum of events that would occur on the pipeline system. But you can see the numbers are relatively flat over that entire period of time if you looked at the average number per year. So we'll go just a bit deeper. These are the categories of failures and the subcategories that go with them. So the second one on the left is corrosion. There's internal corrosion and external corrosion and maybe unknown corrosion, unknown at the time that the failure happened. But those are the big buckets that we categorize our failures that occur on the pipeline system. If we just look at categories, you can see corrosion is the second leading category there, just behind the material and weld failure group. And if you recall from the previous slide, that had like 27 different categories or subcategories in it, so it's no surprise that a lot of things get lumped in there. And if we look at the subcategories, you can see internal corrosion and external corrosion are the number 2 and number 3 individual causes of these significant incidents. So again, we have the definition of significant incidents. If we just carve out the corrosion data from the overall data set, and we look at the 3-year trend, corrosion is the kind of the pie wedge there on from the 1 o'clock to the 2:30 area. 20% of the failures across that span are due to corrosion. If we look at the 5-year trend, very similar number. 10-year trend, again, a very similar number. Does anyone in the audience want to guess what the 20-year trend looks like? I mean, statistics are part of the curricula, right? Yeah, it's about 20%. Very similar number. So not a lot of change in the way this has been managed over that 20-year period. So if we ranked these across the different buckets of what defines a significant incident, 1,140 significant incidents over 20 years, that's the number 2 out of all of the population of those events. There's been 19 fatalities that have occurred in that period of time. Now, this is somewhat skewed. There were 12 fatalities due to one particular pipeline incident that occurred in 2000. Carlsbad, New Mexico, there was a pipeline that exploded near a camping area, and 12 people died as a result of that one particular instance. That's the reason I left the data ending at 2019. If I had gone forward to 2023, that number would have fallen off and we wouldn't have seen the magnitude that you can have from a really bad day in a pipeline incident. $60 injuries over that period of time, and then the cost. So kind of middle of the pack, maybe towards the bottom of the pack related to the impact of all of these failures, but pretty significant nonetheless. We're saying we have a significant incident once a week, basically. That seems pretty frequent. So I'm going to switch to risk, and let's talk about how we might be able to understand and manage or change how we approach the management of corrosion and try to drive down those statistics. This is a really fast risk primer if you haven't had one, but this is a typical risk matrix. You have risk is simply the combination of likelihood and consequence. This shows a 5x5 matrix. You can have 8x8s, 3x3s, whatever you want. Usually it's done in a relative fashion, so it doesn't mean that there's some acceptable level of risk. It just means something might have more risk than something else if you were plotting different types of events. I think one of the important things to recall is there's no such thing as zero risk, right? Whatever happens, there's just trade-offs between how you might lower risk, but you don't get to zero. Living brings with it a certain amount of risk. Coming here this evening, you took on a certain amount of risk in traffic to get here, and going home, you'll have risk going back home. I don't know how it all works. I've been impressed that I haven't seen any mirrors get knocked off or people get knocked over, but it seems to work. Another way to think about risk is using what we call a bow tie because of the shape of the diagram. And on the left side you have what are the threats that we're worried about and what barriers do we put in place to prevent those threats from happening. Once you have an event in the middle of that bow tie, you then have consequences that are going to occur. So what barriers do we put in place to mitigate or make the consequence as small as possible? So if we were to apply this to a pipeline leak, that's the event, right? We lose control of the fluid inside of the pipeline. We would try, in a corrosion sense, to put a lot of barriers in place, like coatings, cathodic protection on the outside. We might have corrosion inhibitors on the inside to prevent corrosion from happening. Once that event does happen, then you have barriers that you need to have in place, like patrolling the right-of-way to ensure that the leak doesn't go undetected for too long. A leak detection system that might shut critical valves to stop further leaks from happening. Pre-staged environmental equipment to be able to clean up quicker. So that's kind of how this comes together. So if we take that bow tie view and we apply it to a risk matrix, again, there's no numbers on here, this is all just relative. We might say we have a risk of something happening that's in this upper quadrant. If we said that risk was a leak, and we said the leak was likely due to external corrosion, we now can put in our barriers, as we talked about on the previous slide. So we have coatings and cathodic protection. That reduces the likelihood of having an external corrosion failure. And then we can apply different barriers to reduce the consequence. And so you end up with your original risk, you apply those barriers, and you still have risk in the system, whatever is the residual risk after that. So you try to drive these risks to as low as practical, and that's about all we can do, right? We have to manage all of this. So in the case of corrosion, we talk about corrosion as being a time-based threat. It happens over time. Doesn't happen, most corrosion doesn't happen tomorrow, it happens over a period of time. So when we build something new, we have all of the steel, let's say carbon steel in this case, all of the carbon steel available to us. And if this was a pipeline or a pressure-containing vessel, we have what amount of steel is required to maintain that pressure, and then typically engineers would add a corrosion allowance or some additional amount of steel, because we're not that good at managing corrosion, so we got to have some buffer. And if we do nothing, over time that corrosion allowance starts to go away. Corrosion happens, our overall wall thickness of the structure we're talking about becomes thinner. We still have an opportunity to do something at this point. We could still apply better corrosion barriers, let's say, improve the coating system. As we go through time and the corrosion becomes more significant, our options decrease on how we're going to be able to save this particular asset, and our likelihood increases that we're going to have a failure. And finally, we get to a point where corrosion management is no longer an option. We have to reduce the pressure of the system, replace the system, re-rate the system for a lower pressure, or shut it down. Right? You can't, there's nothing you can do anymore. You've reached a critical threshold value that you need. So again, as the wall thickness gets thinner, your options become less, and your likelihood and therefore your risk increases. So we'll look at this one more time, same chart, not a duplicate slide. Our goal is to try and freeze where we are on the risk matrix with good corrosion management. As we said, if the wall thickness thins, the likelihood goes up. So if the consequence remains the same, and all we're doing is playing with the probability side, we just go up and down on the y-axis. It's very hard to go backwards once you've increased the probability due to corrosion. So if we can try and freeze it. That's what corrosion management's essentially trying to do. Fix it on the risk matrix so it doesn't continue to move and increase the risk. So that was the risk primer. Everybody understands it, yeah? Good. Good. So then we shouldn't be having any corrosion issues then, right? Because it's pretty simple. This is what we want to do. We just got to go do it. Some of you may have seen this earlier in the week, but this is what is called the unsustainable corrosion management cycle. It's more of a management failure than anything. It's got 4 phases. The first phase is, I don't have any problems whatsoever. I just built this thing. Life is good. I'm not even looking for it because I don't think it's a problem. The second phase is what we like to call panic, where something has happened and now you have to react. There's lots of energy and effort that is expended in trying to understand what has occurred. The third phase is where we start to learn and apply best practice and manage what is happening. The second phase is very exciting for a short period of time, but it wears out quickly. It's like getting up and running sprints every day, all day, for weeks and or months. So I'd encourage you to get through the panic phase if you experience any of this as quick as possible. This is followed by the fourth phase, where everything that we just learned goes away. We haven't had a problem in a while. Why are we paying for all of these different activities? And sometimes leadership changes, people move, roles, retire, whatever the case may be. And new people come in and they haven't had to learn any of these lessons. They never went through the panic phase, so they don't know how exciting it can be. In a sustainable, now this is not the UN sustainability type sustainable, but in a systematic, rigorous process, a sustainable process for corrosion management, we like to think about it in a plan, do, check, and act sort of way. So that's a continuous improvement piece where you plan what you're going to do, you take that action, you look at the results of that action, you make adjustments, and that impacts your plan for the next cycle, and you continuously try to improve as you go through time. And what my experience is, maybe it's just me, but what technical folks are poor at is communicating with business folks. So there'll be a lot of people that will have MBAs as you go through your career, and you're maybe coming from more of a science, technology, engineering side of life, and somewhere the communication of the principles of what's trying to go on, what we're trying to accomplish, just doesn't translate well. So we need to start thinking about how we communicate with each other. And the idea around corrosion management is it's not an expense, it's value creation. It's investment that pays dividends over time, so you have access to the whole life cycle of the equipment. We've already spent the time and energy and money to dig the iron ore out of the ground, send it to a facility to turn it into steel. Why wouldn't we want to maintain that as long as possible? Mother Nature wants to claim it back. If it wanted to be steel to begin with, it would have been steel in the ground. So Mother Nature wants it back. We need to manage it as long as possible. So this is just a quick comparison between unsustainable versus sustainable. If you're not managing equipment properly for any length of time, you will get a lot of help in how to manage it. And that help will come in form of government regulators or lawyers, the legal system that will come and make sure that you do it right. Sustainable management in this instance is kind of dull and boring. There's no big surprises. There's no panic session to go through. It's much better for your health. In my case, it's better for, well, it would have been better for my hairline. But it's just seems like a wise choice, right? We're trying to invest and maintain what, keep the stuff in the pipe that we're trying to move through the system. So there's 5 questions that you could ask, and this is tailored to corrosion management, but this is 5 questions that you could ask in any risk scenario, and it could be applied to any type of equipment, whether it was an airplane, a roller coaster, a ship, or a pipeline. So if you think broadly enough about it, you see that they are very applicable to almost anything. The examples that I use are pretty well tailored to the pipeline data because that's where I think we can make some improvement, at least in the United States. So what are our threats? Who's decided what the threats are? Has it been done in a rigorous fashion? Where's it documented? What was the process to go through to understand what the material is we're going to use and what environment it's going to be exposed to? So, have we been systematic? Have you been systematic in understanding that? They're not hard questions. Next one, what are the barriers? If we understand the threats, then we can understand what we need to do to prevent those threats from coming coming into being. In the corrosion space, we can talk about material selection. That would be what we'd consider a passive barrier. If we had a particular threat that was aggressive to CO2 corrosion, let's say to carbon steel, we could pick an alloy that was resistant to CO2 corrosion. We don't have to do anything with it anymore. By nature, it is passively immune to that threat. Doesn't mean it's immune to every other threat that is out there, but it is immune to that threat. Then there are some active barriers that we would have to design and maintain and operate through time. Those are active. They require continuous involvement and monitoring. So what are the barriers that you've picked? And are they truly going to be effective? And the other thing to look out for is if you've picked a barrier for one thing, are you trying to take credit for multiple things? Because that's not always the case. There's always, let's see, what is it? There's no solutions, there's only trade-offs. So you have to figure out what you're trading off. And then, how do we assess it? How is it going to perform? Is it doing what we want it to do? How is it demonstrated? Have you gone and looked? Have you checked? Is it actually reducing the corrosion rate the way you thought it would be reducing the corrosion rate? Then there's the subject of, we talk about KPIs, key performance indicators. In university, you probably only have a couple of key performance indicators. What would be one? How you did on an exam, what your grade is, that's a key performance indicator, right? Would you think of that as a leading indicator or a lagging indicator? Probably a lagging indicator because that's how you have done to this point, what your grade is. Right? It doesn't tell you where you're going. It tells you how you did on the exam or how you've done on the assignments that you're turning in. What would be a leading indicator in a classroom structure? Could be just showing up, right? The more you show up, the better chances are that you're going to absorb the material and understand what the instructor is trying to deliver. So leading and lagging indicators are an important piece. Sometimes we think of leading indicators of activity-based. Did we do something? We said we were going to go inspect this. Did we go and do the activity? Yes, we did. Check. We've got that as a KPI. The lagging part of that is we went, we inspected it. What did it tell us? Is corrosion happening or not happening? If it's happening, we need to then go back to our continuous improvement, make a change to our plan, and implement that change. So leading and lagging are important concepts. So how are those tracked? Where are they documented? And who's managing or watching them? I said there was 5 questions. What question was that? Just seeing if people are paying attention. This is the 5th question. So, if the performance isn't meeting our objective, what are we doing to fix it? What's the corrective action? That's probably one of the more important pieces. You now have information that says you're not living to the standard that you have set. What are you going to do to fix that? My standard in university was to get B's. Sometimes I met that standard, sometimes I exceeded that standard. But when I didn't meet it, I had to have a corrective action in order to fix it, to raise that bar back up to where I wanted it to be. I was never an A student. So, do we have corrective actions, a process in place to understand and implement corrective actions? And then that goes back through the cycle again. How are they performing? What are they doing? What are we getting out of it? So we'll do a recap here. So for the U.S. Infrastructure of regulated pipelines, we have one significant event roughly a week. That seems like a lot. That's somebody's life being changed either due to an injury or their family's life being changed due to death or a big impact to the environment. So that seems like too much. And we haven't really moved the needle over 20 years worth of applying technology, more prescriptive regulations, better inspection techniques. Technology has improved significantly over that period of time, but we haven't really changed the performance where it matters. And you could argue, yes, but we're building new pipelines. We are, but I'd also argue that the bulk of the infrastructure is getting older as we go. So it's not going to get any better to manage as we go. Corrosion certainly has played a role in that. And from my standpoint, or the disciplines that I look after, we're trying to do what we can to change the narrative and the trajectory of those trends. So we're directly connected to risk, trying to freeze that on our risk matrix, trying to change the narrative to be more of a conversation about investing in the assets and returning business value over the long term versus having not being able to communicate well with the financial aspects of the business. And we do that through a rigorous process of looking at, stating a plan, executing that plan, and making adjustments as we go. Well, let's see here. So those were the 5 questions in this Plan, Do, Check, Act scenario. understand the threats, understand your barriers, and do performance management as you go. I was going to close with that slide. Certainly happy to take questions. I had one small thing I forgot to mention at the beginning, so we got to go all the way back to the start. Just kidding. You know, I was reflecting on the lunar landing that occurred earlier this week, and fantastic accomplishment. We were in the offices in Pune, cheers all the way around, and it was wonderful to see. About almost 55 years ago was the Apollo mission that Neil Armstrong landed on the moon. And if we think about the technological change that has occurred, there was a post by Google in one of their networks that these were Google employees, data scientists at Google. And what they said was the amount of computing power used in one Google search, so if you were to search Apollo 11, that search is more than all of the computing power that was used for all of the Apollo missions, space and ground, for the 10 or 11 years that Apollo was running. That's amazing. I mean, think about the supercomputer you have in your hand and how many Apollo missions you can run just by searching things. So with that, I'll close. If there's questions, happy to take any questions, or I don't know what happens next. What do we do next?
Is there any question? Can you just put that last slide? You want to ask?
Yeah, I just want to say, when you consider the barriers, you specifically talk in terms of plan, do, check and act. These are the 4 steps which you essentially take. So when you consider barriers, are these barriers are not considered during planning stage?
Sure. If you're talking about building a project and let's say we're starting with something new, you'd absolutely want to know what the fluids are that you're managing, and you'd you'd write a corrosion management strategy, do material selection during that project plan stage.
Yeah.
Absolutely. That's not really a continuous improvement cycle, but planning in a project sense is definitely one of the key phases. And so yes, you'd make those decisions. This is more about ongoing, let's say in year 5, you've got to have a plan for what you're going to do this year. What is that plan going to be?
So this is essentially maintaining the integrity of the system after it has been designed based on whatever the best knowledge database which was available at the time of planning and design.
Yes, and
because that keeps on improving, and add-ons to it is when you get an opportunity to improve in the planning, to what extent the do part can be added when you want to incorporate the new learnings or new data which you get into that part. Meaning a section of a pipe is to be changed, let's say for example. The bends needs to be changed, for example.
Mm-hmm.
So that's a sort of in between planning and do.
Yeah, I mean that would be a major change to the asset that if it was a pipeline, the major change to the pipeline that we're trying to manage overall. And now you certainly need to understand what is the impact of this new segment, or maybe it's an additional segment that got added. What's that impact to what my plan was last year when that segment did not exist? I think the other thing to remember is we're probably not stationary in how things change with time. So the fluids, the environment changes. They might come in and put a parking lot over the top of your pipeline that didn't exist when the pipeline was built, just due to, as population changes. So now you have to think about, what does that do to my ability to manage that particular pipeline? I take your point. I mean,
And I also take your point. Essentially, the pipeline where it was originally put up considering a certain set of environment,
Yeah.
that environment may also change over a period.
Yep.
And then it might not be worthwhile, not be economically viable to change that pipeline. But that is where the barriers and the performance assessment of those barriers probably can be considered, can come into picture. I understand that.
Yeah, I mean, and a great example is live today, right? We're trying to understand how much hydrogen that you can inject in a natural gas pipeline safely, because that changes the fluid, changes what the pipeline was designed to, introduces new threats that you have to have proper barriers for. And so if you hadn't maintained that pipeline and you don't know its current integrity over time, then you've got a lot more unknowns to deal with than if you do know how it was managed and maintained over time.
Thank you.
And it's very much a live discussion in Europe, in the US, and in a lot of places as we look to transition into hydrogen.
Thank you.
Thank you.
I'm Anil Bharadwaj, fellow AMPP. I worked for 40 years in oil and gas. My question is, what will be the major ingredients for corrosion risk assessment to make it most effective?
To make it most
Effective.
Well, see, I only have 30 years experience, you have 40. So what would you suggest? I think there's, we have to look at the impact of technology that is playing out today. Vastly improves our ability to do risk assessments. If you look at whether it's the application of drones, whether they fly, swim, crawl, or walk, their ability to get data, the ability to have cheap and low cost and reliable sensor technology that you can deploy in far more locations than you could before, giving you information back on the integrity or how things are performing. Those definitely feed into risk assessments. I think the challenge is going to be, you'll have more data. Now, how do you turn that data into information and be able to integrate it and take action on it sooner than what we might have been able to do previously? Risk assessments, in my experience, the biggest challenge with risk assessments is people don't recognize these small changes that add up over time. So a creeping change, if you will, that the fluid properties have changed somewhat over 20 years and they no longer resemble anything of what the design-based fluids were, because we might have drilled into a new production zone, or we might be bringing in other entrants into the pipeline system, another third-party entrant into the system that has a completely different fluid characteristic. So recognizing change is probably the hardest thing, because you're standing so close to it, sometimes you don't see it. I don't know if that answered how to make it more effective, but those are things that I think will impact how we can do them, how we can do a risk assessment in a more systematic way. But I'd be happy to hear your thoughts on how best to do that too. I mean, there's no perfect answer.
Good evening, sir. I am a final year chemical engineering student from Datta Mege College. My question is, in a pipeline, we can identify the external corrosion, but we cannot identify the internal corrosion. So what is your take on this? How to manage it if we can't see it?
Yeah, most pipelines that are built today and that have been built really, at least in the United States since the late 1970s, are capable of having a tool called an intelligent pig or an inline inspection device. And that device, you put it in at one end, you launch it, it goes through the length of the pipeline, it's received at the other end, and it has sensor technology on it, either ultrasonic sensors that constantly measure the wall thickness as it goes down the line. That's usually used in liquid systems. For gas systems, because you need couplant between the metal that you're measuring and a UT sensor, so you need some fluid there. For a gas pipeline, they have what's called magnetic flux leakage, where it has some big magnets on it, and it looks for distortion in the magnetic field as it goes through the pipeline and records where those are. So we can pretty reliably detect internal corrosion and external corrosion using those two techniques. They're periodic, right? Every 5 years, 7 years, something like that. So you have to take the information it tells you, that's important feedback, and do something with it. It's a KPI. So if we've got internal corrosion, what's causing it? And what now do we adjust our barriers to account for it? Did that answer? Internal is a lot harder than external for sure, but
Any other students?
Hello. In your experience, hi, I'm Salil Narvekar. I was a student of India, Institute of Chemical Technology, this college itself, and now I work in the strategy department of a chemical manufacturing company. So my question to you is, in your experience, what has been the typical trend of the life of a pipeline? Has the typical life of a pipeline increased due to technology? Has it remained the same, or has it actually decreased because now people are looking more into the use and throw culture? So I just wanted to know your opinion about that.
have you dealt with many corrosion engineers in your career so far?
No.
So we like to say it depends a whole lot. So the answer to your question is it depends. There's plenty of examples of pipelines in the United States that are built in the 60s, built in the 50s, probably a few examples of built in the 1940s that are still in operation today and have, through good corrosion management technology, have been, in continuous service, reliable service over that period of time. We go to the trouble of building these, relatively expensive equipment, whether it's a chemical plant and pressure vessels associated with all of that, or a pipeline that traverses a long distance. And being able to maintain them can be a challenge, but it's kind of what we're supposed to be doing. I think we've made the investment, so let's maintain the asset. There's no reason that we can't maintain them. But sometimes there is a practical limit as well. So if you designed, I worked for BP in Alaska for a number of years. We had an incident in 2006 on a 34-inch diameter pipeline, and it was due to all this change. The throughput, the amount of production coming from the Prudhoe Bay in Alaska at the time was about a third of what the throughput was when it was originally built. So now you got this great big pipeline that is no longer needed because it's just the volume isn't there. But you have to maintain that like it was, and that introduces different threats and barriers, and if you're not in tune with what that is, you end up with a bad day. So it's change related, I guess, is what I would say, and sometimes you need more volume, so they'll build another pipeline alongside of something as well. But you can practically maintain, I think, infrastructure with the right set of tools for a fraction of what it costs to replace infrastructure. And I think that's the key point, right? Let's manage what we have and not have to go out and buy new all the time.
Yeah. Good evening, sir. My name is Harsh Jala. I'm currently AMPP India Secretary. I'm currently working in JSW Steel Industry, I wanted to know that as a steel industry plays a major role in carbon footprints, so how we can, how the preventive corrosion measure can take our steel industry plant more sustainable? Any thoughts on that? How the corrosion and steel industry going to be related?
Yeah, I think it's a great question, and it's a complicated question. There's lots of data and statistics that go into any one that gives you an answer. What I'd say is the manufacturing of steel, that footprint or that CO2 footprint probably will be impacted by being able to move to hydrogen as a fuel or some alternative energy aspect of the fuel. That will reduce the footprint of being able to manufacture steel, and that's probably the largest portion of the CO2 footprint that exists relative to that. Once you have your pipeline and you put it in the ground and you're running it, short of maintaining it, the CO2 footprint is not that big anymore, right? All that investment occurred, or all that energy occurred at the manufacturing point. So changing how it's manufactured, or what the energy source is to manufacture, is where the biggest impact is going to be on CO2. I mean, I tend to think of corrosion as one of the original sustainable engineering disciplines, right? We're maintaining something for as long as we can. In a circular economy, that's a great way to be. But the reality is the energy that went into making it is where all of the CO2 sits. So how do we reduce that is going to be where I think where we'll see the market shift. What are they doing at your facility? Are they talking about how they're going to change the energy source to supply?
I think before I close, Tim, I would like you to say something about the opportunity for the chemical engineering, graduates in British Petroleum, particularly in India operations. How it is going to be?
Yeah, sure. As I started in the introductory comments, we're getting ready to increase our engineering footprint in Pune specifically with the broad spectrum of engineering disciplines, whether that's material, electrical, mechanical. Certainly chemical engineers play a big role in process engineer. They play a wide diversity of roles. You can end up in any number of locations. So there'll be an increase in engineering and in BP here in Pune coming up in the next 12 months or so. From a graduate recruitment standpoint, I think initially we'll be trying to bring in some later mid-career expertise to put a footprint in for a team, but we will be building the team out as we go through the next certainly 12 to 24 months. And it will be several hundred engineers that will be coming into this. And this is not setting up a location, this is having a hub, an engineering hub that would be similar to the type of work that we do in our Houston hub, where we have a core group of engineers, or in our London hub where we have a core group. So it's just another place where we want to grow and expand. So I think if you're liking energy and liking what the types of things that you think BP is headed towards, and we certainly have a website and you can go read all about how we're trying to do the energy transition, then I'd stay tuned to LinkedIn and other sources for looking out for opportunities. And happy to share contact details if that is of interest to anyone. That's happy to do that.
Thank you, Tim. Let us give a big applause to you.
Thank you.
Okay, so I think we had good 2 sessions, and one has initially about the true sustainability, and second the technical. So that is how it should be, I think, when we are organizing any lecture covering both the aspects. I think now we have a few announcements before I go to the final vote of thanks. One is, I think, Mr. Sandeep. Sir, you wanted to announce anything? Yeah.
You know, as we as an association transition from NACE and SSPC to AMP, our whole structure for professional development changed into what we call the Emerge program. And under the Emerge program, we have scholarships with Dr. Kamachi announced a little earlier. But there are opportunities for all across the spectrum, from the student all the way to somebody who's retraining or entering a second stage of life. Even a 60-year-old wants to do something new. We have opportunities at AMP. So we encourage you to go to the AMP website, ampp.org, and look at the opportunities that come in. One thing I'd like to emphasize on what Dr. Kamachi told you about the 10 scholarships that are funded by us. It's only funded by us, but it goes through the whole AMP system. So that scholarship, when it comes to you, it's a global scholarship. You are as equivalent to anybody anywhere in the world. And that's the value of that scholarship. And I'm very happy to say I was chasing Dr. Maske last year to get somebody, or year before, to encourage somebody from ICT to apply. And I think we had one student from ICT who received that scholarship. So I encourage you all to apply for it. It's a great reward when you get to meet people at our annual conference in the US, the 6,000-7,000 people at a time. And it really gives you opportunities, and I strongly encourage you to get involved. And Vice Chancellor sir, I also request that one of the issues that came up, and also something that Tim mentioned about his Prudhoe Bay pipeline. One of the issues that comes up is we've had these meetings, technical meetings with GAIL also, every quarter. And one of the times they discussed was the moisture allowed in the pipeline. And the values being discussed in that meeting were, oh, you know, we are here and we use this value, Reliance uses some value, GAIL uses another value, BPCL uses a third value, but none of it matches a standard. And the reason for that is very simple, because the people who wrote that standard all were in the same environment, which was something like Alaska. So unless we as Indians also participate in these committees and give our experiences, how is that standard going to work for us? And to be part of any standards committee, you don't even have to be a member of AMP. All you have to is get onto the website, make your ID, and join any group that you wish. And our whole standard system has also been revamped in the last 5 years. So as Tim has been on many committees, will say it takes so long to get a standard out. And we are trying to reduce that time to less than 5 years for making a standard. It's, I think, down to, I don't know how much, less than 5 now.
Some have achieved 12 months, but the norm is
Yeah.
really 2.5.
Yeah, so that, I mean, because the standards have to be relevant. Yeah, so we encourage, students also get on these committees. You can hear things, discussions that are taking place in any field that's of your interest. Okay, thank you very much.
Okay. So nice of you. I think regarding the standards, I think students should, Google it out, how many standards are available and why so much time is required, because standard is something which industry is still confused when we talk about, how certain test pressures or whatever is fixed. Okay, now Akash. Okay, you can come. We have OIC at IIT. So Akash is over here. He is an executive council member at IIChE MRC as well, and from IIT, associate professor, I think. And he wants to invite everybody to OIC being conducted at hosted by IIT Bombay.
Hello, myself Akash Shinde. I'm working in IIT Bombay. This time we are organizing OIC. OIC is Outstanding Young Chemical Engineering Award, and this time we are organizing it in IIT Bombay in association with IIChE. So we invite all the participants. There are two categories. One is for working professionals who are under 40 years, and other is for undergrad students. More details are available on IIChE MRC website. You can go through that. And the last application date is 27th of September, and the event will be on 7th of October. So you can note of that, and you can participate through the link. Thank you.
Yeah, and OIC is a very old and flagship event of IIChE MRC. It was specifically designed to promote people from industry to participate and present their lectures, because usually when we have presentations, the people from institutes take over and it's difficult for people from industry to present it to that scale. And it's a prize money involved. ThyssenKrupp, formerly Uday, is sponsoring the Working Professional Awards, and Bhumista, the other company, for UG category award. So yeah, okay, थोड़ा calculation करना पड़ेगा. Okay, ThyssenKrupp is in 50,000 rupees is being sponsored as a prize money. So I think first prize is 25,000, second is around 15,000 and 10,000, the third prize winners.
Sorry to say, but apart from money, it will be more it will be a motivation to work in the same field, and it will give you some motivation to work like in research, who are in undergrad. They will get promoted by these awards, and these awards will be very helpful if you mention in CV and other things for any of other applications.
Right, and similarly for UG category, it's I think around 8,000 or 6,000 and 4,000 rupees, first, second, third. So it's just a token of appreciation from the industry to promote more and more participation, as Akash mentioned over here. And we are happy to receive participants from college and industry. And our Mudli sir, I think we had last time, because of this COVID, we had a positive note that it became into a, turned out to be a hybrid mode, and we got participation all over the India, and I think more than 20-25 papers were collected throughout the industry. So that was a good thing, and let us hope this time again. So thank you, Akash. I think now we are at the end, and luckily this time I think we are before time. So that's the best part, I think. So sir, we would like to honor our speakers over here. Shri Professor Pandit, Vinay sir, PK sir, please join Pandit sir to, sir Mudli. Yes. Okay, so Dr. Shrikant, Parab, we are thankful to you for yeah. So we have Mr. Timothy Bieri. आइए नागेश्वरी जी. किधर गया चेतन. We'll be having a group photo as well. Okay, so please do not leave the hall, inside and outside both. Okay, so, sir, I think for senior members we got flower. So I would like to thank Mudli sir. Just a token to Mudli sir, we can hand over. Yeah, Professor Pandit can hand over to Mudli sir actually. Okay.
Previous chairman.
To the previous chairman, welcome back to Mumbai.
Thank you.
And,
I think the towel is agitating probably. Praveen Saxena was the chairman of this in the year 2010. And so what you are seeing it here, and he is mostly for the last many years sponsor for his shirts to all the ClinicCons. So I think, and he's the one. And then probably I can go from him in subsequent years. So from 11 to 14 I was there, and we had a very good seminar done along with Dr. Pandit. And the immediate past is Dr. Mudri, and current one is our
yeah. And Srivastav ji, our former president of IIChE.
Yeah, thank you.
Past chairman IIChE MRC. Yeah, I think. Yeah.
Yes.
MP Jain sir, and I think they are. He's also former chairman. Dr. R.N. Trivedi ji, I think it is always good to see you, sir, over here. And I think Vinay Srivastava uncle has already many times informed us that हमारे इंडिया में गुप्त दान का प्रचलन है, जिसके लिए हमारे त्रिवेदी साहब फेमस है. So we don't, many events he has supported. He is always there at the AGM.
I am chemical engineer from Banaras Hindu University, 1961.
From Banaras Hindu University, 1980.
From BHU, 1980.
80.
बहुत दूर हो सर 61 और 81
Rastogi sir, actually, let me add a little more. Rastogi sir is actually 5th batch of training school, BRC training school, and I joined with the same organization 15 years after. So I will not tell, now we are all touching 70, then you can imagine his and his enthusiasm of being here present amongst you.
So his energy level, I think that let me also share. I am a veteran of 1971 Indo-Pakistan War.
Yes.
Okay, I think Sir Samir ji, and we can just, to make it more memorable,
आप तो रहेगा सर
yeah, I think Kulkarni, I think. Ma'am, I think you can also please, as a memory.
Oh, yes, yes, yes.
Okay. Okay. And yeah, just sir, हमारे पराग गोगटे साहब आए हुए हैं. So he national council member. So we should at least
With penalty.
वो नहीं तो घर की मुर्गी दाल बराबर हो जाती है. तो it shouldn't look like that. So Dr. Parag Gopte.
मेरे को लोगों ने टी शर्ट वाला के नाम से कह रखा है. So I'm known in the IIChE.
TL Prasad Sahab, the now elected council member, but his tenure will start. I think this is the third time he is getting into the national council, being elected, and got more than 1200 votes this time.
मैक्सिमम क्यों?
हाँ, this time.
कोई नहीं आया अभी तक. नहीं, 2 ही बार का रिकॉर्ड है कि 3 बार आ चुका है कोई.
आपको याद नहीं हम कितनी बजे हैं. चलिए. Okay, so I think we may be short of roses, but the other gifts are already available. Parvatalu Sahab, and just we'll distribute. But to end this session now. Yeah. So we can call अभी बोला अच्छा okay. तो Madam Deshmukh Madam, she is the HOD of Datta Meghe College and just retired, and I think I should say Deshmukh Madam, वो मेरे भी kind of mentor from conducting OIC. I think 3 या 4 OIC तो कर दिए थे मैडम आप. आइए. And she has also been at Mumbai University. इस बार नसीब है आपके दर्शन हो गए बढ़िया, तो वरना तो कॉलेज में ही होते थे. Actually, now Satyajit Sahab is the HOD of Datta Meghe. Madam has just retired, and he is also here.
I just want to make one correction.
Yeah.
I'm retired now. I'm
Yeah,
not
I told-
HOD.
I just told.
Professor Dr. SM Deshmukh is there.
साहब चिपक जाता है.
हाँ जी.
तो आपके साथ छुट्टी देखिए.
चिपक गया.
दत्ता मेघे है ही. तो अभी आप
अरे सत्यजीत साहब,
Surname was an unknown.
लीलामणि मैडम कहाँ गए? आइए मैम प्लीज. आई ऑलवेज से वो मैडम हम लोग की उम्र पता चलती है, आप लोग की नहीं चलती है. और अब मैं पाँव छूता हूँ तो थोड़ा मना कर देते हैं सब लोग. Madam is from Jonle College, and Jonle is our corporate IIChE member. She has a lot of activities. I think Pradnya Madam was there, but okay, she is the EC, newly elected EC. And we have over here Ankur Chaturvedi. He is completed his PhD from ICT only. So the newly elected IIChE EC member, Ankur Bhai, and Pradnya Ingle Madam. Yeah. So I think
अच्छा हाँ ये भी है. इसी में नहीं.
नागेश्वरी जी इस बार सर जल्दी हो गया तो और गुलाब भी बाकी है तो Ankur is from industry and he has his unit at Ambernath. So I think we were asking, sir, that one more entrepreneur from ICT having his own API industry at Ambernath. पंडित साहब को
in MRC we have got the 7 students chapter and it is good to see as many as can join the AGMs. You know, normally attendance is very thin and they used to be coming also from Dr. Pandit long ago that early 25 people used to come, but I am seeing more than 50 now here. So that is very important here. So it is a good attendance and I will request you at this lecture, please do participate because there is a lot of things you will try to get it. And good, thank you Dhaval for adding 2 good lectures on the presence, so numbers are also good and everyone who is here, I am sure they must have got a good benefit of coming over here.
Okay, I think sir, Ketan and just our Salil, the coordinators, we can just help them. Bina inke to sir, no presentation, nothing. So, you know, it is always. So he is Salil, he is also alumni of ICT, recently passed out and joined Aarti group. Ketan, yes. Okay, I think so I think we can conclude now. So finally I'll propose the vote of thanks for this session. So first of all, this is we expected actually to have a single lecture then and it's just a week ago that everything got framed out so well that we are over here to have Shrikant Parab ji, Mr. Timothy Bieri to make this AGM more memorable, which will be there starting at 6:30. So I thank first of all ICT for becoming the next home for IIChE, MRC like always, and I think so many such lectures are being organized and Pandit sir being the VC and the chairman of our IIChE MRC, so it has never been never been a problem for us to organize any event. On the contrary, when we are at ICT we feel that there is no difference between IIChE and ICT, so that is the beauty. And we have a good list of people from Professor M.M. Sharma, Dr. Yadav, Dr. J.B. Joshi, Professor Pandit. I think he has lot of already patents, and I think I used to hear him out when I was at college that certain projects are installed at so many villages and also. I was just recollecting when Dr. Parab mentioned that you have worked on many projects at your society. I thank this our CII Corrosion Management Committee, and Dr. Kamachi Mudli is the president right now of National Corrosion Management Committee. I also being a member, so it's a joint effort and jointly being done. Also this our AMP, then CIC for making it contributing and jointly putting the efforts to make it a first event. I would say all the supporting organizations have come together over here to make it a much better, bigger and good communicative interactive session. So I thank all the supporting organizations. We have circulated the banners everywhere at the same time. I hope that this session as you are going to have a good takeaway when you say that you have interacted with so many people and variety of people, people from industry, people from academia. So it's a very good gathering. And apart from that, I think if I'm missing something or if I miss someone from, so please I apologize for that. And we would like to say that we are looking forward for much more seminars, much more interactions from all the chemical engineering fraternity that we are having at IIChE MRC and the industry from IIChE MRC. So thanks a lot. Thank you everyone for making it over here. Thanks a lot. Yeah, we have high tea, and yeah, we can have a photograph over here, sir. I think inside and also at the entrance gate of ICT, just as a memory. So after the photograph, high tea is being served.